Have you ever tried to build a machine learning model only to find it just won't converge? It's frustrating, right? If that's you, then you're in the right place. Today, we're diving into a perplexing issue. Why does the same model converge in Keras, but not in TensorFlow? I completely understand how disheartening it can be when your model just gets stuck at a certain loss value. You're not alone in this struggle. Many developers face similar challenges when transitioning between Keras and TensorFlow. Here's the specific situation we're looking at. One user recently asked, "Why is my TensorFlow model not converging while the Keras version does?" They mentioned that their model gets stuck at a loss of 0.69. Sound familiar? If so, let's dig into this together and find a solution. So, what could be causing this issue? The difference in padding methods between Keras and TensorFlow might be a factor. In Keras, padding is done before the sequence, while in TensorFlow, it's done after. This can affect how the LSTM processes the input data. And don't go anywhere. I've got a crucial tip at the end that could help you troubleshoot this issue effectively. First, the user should check the padding method used in both models. In Keras, the user is using pre-padding, while in TensorFlow, they are using post-padding. This difference can affect how the LSTM processes the sequences. Next, the user should ensure that the sequence lengths are consistent across both models. Since the user mentioned that limiting the sequence length to 100 allows both models to converge, this suggests that longer sequences may be causing issues. Additionally, the user should verify the LSTM cell configurations. The user is using a basic LSTM cell in TensorFlow. They should ensure that the parameters, such as the number of units, are identical to those in the Keras model. Finally, the user should examine the optimizer settings. While both models use the atom optimizer, the learning rate and other hyperparameters might differ. The user should ensure they are set the same in both implementations. Did you know? The first LSTM networks were developed in the 1990s, and they were a game changer for sequence prediction tasks. We've come a long way since then, but some issues still stump us. Now let's look at the answers provided by other users. One user suggests checking the initial values of your operations. They found that the eta-delta optimizer in Keras had an initial learning rate of 1.0, while in TensorFlow Keras, it was set to 0.001. This difference caused the model to converge much more slowly in TensorFlow. Here's the crucial tip I promised. Always keep your models as consistent as possible when switching frameworks. This can save you a lot of headaches down the line. And there you have it. With these tips, you should be able to troubleshoot your TensorFlow model effectively. Remember, consistency is key. If you found this helpful, hit the subscribe button for more insights, and don't miss our next video on optimizing LSTM models.